So I'll be doing, this is an extra class actually for AP Microeconomics. So I'll be just doing one question on marginal benefit and analysis. And before that, but let's just do the answers to the MCQs for comparative advantage and also to the marginal benefit and analysis that I had given you in my last video. All right. Okay. So going back to them, comparative advantage and trade, right? This was the first question. Which of the following statements is true about specialization and trade? So what's the answer? Okay, it's option D. A country should specialize in and export the good for which they have comparative advantage. All right. Okay, moving to the next one. Just a minute. So as I told you earlier also in my videos, if any of you want, classes for AP Micro and AP Macro, I also take that, right? And my number is 9818787071. You can always contact me on that. I'll be highly honored. Okay. Then I have the second question as this. Which of the following situations would allow agents to gain from specialization and trade with one another? So these 5 MCQs I had given you in my last video. I'm just, doing the answers with you so that you know what's the correct answer. And if you have a wrong answer, you can just correct it and understand it. All right. And the answer is option A. The terms of trade are between the two agents' opportunity costs. That's what I told you, how to calculate the terms of trade. It will always lie between the opportunity cost for the two agents or two countries or two individuals, right? Only then they will have gains in trade. Okay. When they have different opportunity costs, right? Using the same amount of time and resources, Kim can write either 10 articles or complete 5 worksheets, and Lee can either write 3 articles or complete 9 worksheets. So if they specialize in trade, who would specialize in each good, right? So that's an interesting one. I'll go back to my screen before I do this question so that I can actually explain you this one. So in this, you have to calculate the opportunity cost for both of them. You can actually calculate either for just one good and you will get the answer. Or if you want to calculate it for both goods, fine. So, all right, I'll be keep switching between the windows, right? So that you see my answer also. How do I write? So Kim can write either 10 articles or complete 5 worksheets, all right? Okay, so for Kim, if I want to calculate the opportunity cost for articles, all right? So the opportunity cost for articles for Kim would be 10 articles or 5 worksheets. So it would be 5 by 10, right? For articles, it would be 5 by 10. That makes it half of your worksheets. So for every one article that Kim writes, he has to sacrifice half of the worksheet. And the opportunity cost for the worksheet for Kim would just be the reciprocal. So it would be 10 by 5. That gives you 2 articles. So for every worksheet, Kim has to sacrifice 2 articles. All right. Now let's see for Lay. So Lay, Leah, right? Opportunity cost for articles would be what? Can either write 3 articles or complete 9 worksheets. So for articles, the opportunity cost for Lay okay, it has gotten somewhere. So the opportunity cost for Lay, the opportunity cost for articles would be 9 by 3 because it says it can either be 3 articles or 9 worksheets. So it would be 9 by 3, right? So 9 by 3, that gives you 3 actually opportunity cost for articles. So 3 worksheets. And opportunity cost for worksheet for lay would just be the reciprocal 3 by 9, which is 1/3 of the article. All right, so now you just compare the opportunity cost for both of them. Okay, so as you can see, for Kim, the opportunity cost for articles is half a worksheet, whereas for Lee, the opportunity cost for articles is 3 worksheets. So obviously, Kim will specialize in writing articles and Lee will specialize in worksheets, because for Lee, the opportunity cost for worksheet is just 1/3 of the article, and for Kim, it's 2 articles. So whoever has a lower opportunity cost will specialize in that good. So Kim specializes in articles. So let's see if we have that option out there. So Kim should specialize in writing articles. That's option A. And Lee should specialize in worksheets. All right. Okay. I really don't know how has it come here. Give me 1 minute. Let's erase all this. Right. Okay. All right. Okay. So it's option A for third. So Kim will specialize in writing articles. Lee should specialize in worksheets. Okay. Joya can make an apple pie in 20 minutes and she can prepare a turkey in 60 minutes. Chris needs 25 minutes to make a pie but requires 100 minutes to prepare a turkey. Again, now that was the output table given to you, and this is an input table given to you because it's given in time, right? The minutes that are basically used in the production of 1 unit of a product. Okay, so let's say based on this information, we should focus on making, who should focus on making turkey for Thanksgiving dinner. So if we just have to calculate for turkey, actually, what's the opportunity cost? Okay, I'll go back again to my board. All right. So for Joya, opportunity cost for turkey would be 60 by 20. So opportunity cost for turkey would be 60 by 20. That gives you 3 of apple pie. And for Chris, the opportunity cost for turkey would be what? 100 by 25. So it would be 100 by 25. That gives us 4 apple pie. So since Joya has lower opportunity cost in turkey as compared to Chris, 3 is less than 4. So that is why Joya will be doing this. All right, she would be specializing in turkey. Do you understand? So it would be option B. All right. Okay, this was the same one. So I had given you actually this one. Max and Ellie like to build apps and coach soccer. This is the table matrix given to you. You have to answer which person has an absolute advantage in building apps and which person has an absolute advantage in planning soccer drills. Now that's a very easy one because you just have to compare the number of hours for both of them. So time to build an app for Max is 20 hours and for Ellie it's 15. So obviously Ellie is more efficient in building apps. And time to write a soccer drill for Max is 5 hours as compared to Ellie, who takes about 9 hours. So Max is actually more efficient in soccer drill. So Ellie would specialize in app and Max would specialize in soccer drill or has an absolute advantage, right? So the option would be which one? It would be, I believe, C. Ellie has an absolute advantage in building apps, and Max has an absolute advantage in planning soccer drills. All right. Okay, this is as far as your comparative advantage goes. And now for the last subtopic, for the marginal analysis thing. Okay, I had given you two questions of cost benefit, and then I had moved to the marginal analysis one. So the first one was, which of the following best describes an optimal choice? And what's the answer? So basically, option C, the choice that maximizes the difference between total benefits and total costs. Correct? Far as deciding whether or not to invest in a project, this project cannot be broken down into increments, and she has the choice of either investing in it or not. So, what's true about her decision? Since it cannot be broken down into increments, so option E is actually ruled out, and other options are also not rational. So it's basically that she should examine the total cost and total benefits of the project, right? So we did that, when the total cost and total benefits, and then we calculate the difference between the two, and if the net benefit is coming out to be positive, then we go for the project, and if it's not, then we don't go for the project, right? So the option is C. Then, okay, I moved to the marginal analysis thing, and that was the table I had given you. So now, given this table, which of the following best describes the pattern exhibited by Anna's utility from drinking coffee? That's very simple. You have the cups of coffee, you have total utility. What you have to really calculate is the marginal utility for this. Now, the marginal utility, I'll do it here, is very simple, right? Marginal utility of for drinking cups of coffee. For the first one, it would be the same as 5. Then it's 9 minus 4, 9 minus 5, that's 4, divided by 2 minus 1, that's 1. So it's 4. So denominator in this case is always 1, 1, 1. So you just simply subtract, the next value to the previous one. So then you go with 12 minus 9, that's 3. Then 14 minus 12, that's 2. 15 minus 14, that's 1. 15 minus 15, that's 0. And that gives you minus 1. So basically, it's option A, that the total utility or the utility Anna gets is increasing at a decreasing rate. I told you in my video that marginal utility is nothing but the rate at which your total utility is increasing or decreasing, since this is nothing but the slope of your total utility function, right? So until it hits a maximum value, right? It hits a maximum value at 15, and then it begins to decrease, and then it begins to decrease the utility. All right. Okay, so it's option A for you. All right, so I'll move to the next one. The table shows Karina's marginal utility she experiences when she visits Wild Waves Water Park. So that's now the marginal utility given to you. According to this, you have to provide Karina's highest total utility. How many visits will Karina have, right? So now just look at the marginal utility. Just now I showed you that marginal utility would be 0 when your total utility is max. 0 is not given, but what's the minimum number for marginal utility after which it starts declining? So at 2, that number of park visits is 6. Beyond that, the marginal utility goes negative, which basically means that the total utility starts declining. So that's the maximum number of visits, park visits she will do, right, in order to have the highest total utility. So it's 6. Your answer is 6, which is option E. All right. And then you have the last one is this that I had given you. So that's again the total utility. It's a gym membership every time he goes to gym. Again, what is the maximum number of times Enzo will go to the gym? So again, you will calculate, you will see where the marginal utility turns out to be 0. And that turns out to be 0 over here. 170 minus 170. So that gives you 0 as the marginal utility for the for 7 number of visits. So basically, he would go 7 times. So that's option C that you have to mark. All right. Okay. So with this, I have actually done all the MCQs regarding the unit 1 that I had given in my previous videos, the answers to all the MCQs, right? And now I'll be doing that one particular question I really want to do with you guys so that you understand fully how to calculate the the optimal bundle of the optimal bundle for any individual given the total utility or the marginal utility and the quantity of goods. Now this could actually come as a free response question to you as well in AP exams, or they might ask you in a MCQ as well, right? Okay, so let's start with this. All right. All right. So it's a question on marginal analysis. All right. Okay. Let's say that Anita has a fixed budget. Okay. She has a fixed budget and of which is equal to, let's say, $20. All right. And she spends on two goods. So two goods are in picture, right? Good X and good Y. Okay. The price of good X is given to be $4 per unit, and the price for good Y is given to be $2 per unit. Okay. All right. And I have also given you the quantity of X, okay, that she has or she consumes 0, 1, 2, 3, 4, and 5. And I have also given you the total benefit of that she gets from X good or the total utility. I told you they both mean the same, right? That's one and the same thing. So it's your $0, it's basically then $16. Then I have $28. Then I have $36. 0, 1, 2, 3, 4, 5. Am I missing something? So 0, 1. Okay, fine. My bad. So that goes for this goes for this goes for this goes for this actually. And for the fourth one, I have $40. And for the fifth one, I have $41. All right. Okay. Then let's leave some space and I divide this with my second good. That's QY, the goods she consumes. So it's 0, 1, 2, 3, 4, and 5. And again, I have the total benefit from Y or the total utility from Y, which is given out to be $0, then $10, 18, then $10 and $18, and let's say $24, $28, and $30. Now that's better. All right. Now I have given you few questions, let's say, based on this, right? So my first question is, so I'll be coming back again to this table. My first question is, okay. My first question is, what is Anita's marginal benefit of the fifth unit of good X? So you have to calculate Anita's marginal benefit for good X for the fifth unit. Okay. Marginal benefit for good X for the fifth unit. What is it? That's what we have to calculate. Now, going back to the table, obviously, this we cannot calculate from the total benefit. We have to calculate marginal benefit, right? Let's calculate marginal benefit for good X, or we also call that marginal utility for good X. I told you it's one and the same thing. So you simply just so that's again 0, right? You can say, and then you simply just subtract, right, from the numbers, since the denominator would be just increasing by 1. So just for a recall, your marginal benefit, I'll write it somewhere here, maybe up, right? I'll write it. Just for recall, marginal utility is or benefit is given by change in total utility or change in total benefit divided by change in number of commodity consumed. All right. So yes, they both are respectively the slope of the total functions. And yes, in order to calculate, it would be what? It would be here, it would be 16, and then it would be 12. So 28 minus 16, that's 12. 36 minus 28, that's 8. And then you will have 4. And then you will have 1. 41 minus 40. All right. Similarly, let's calculate your marginal benefit for your y or marginal utility for y, right? So that is easy for the next part. So again, it would be 0, this would be 10, it would be 8, it would be 6, it would be 4, it would be 2. All right. So marginal benefit for Anita for 5th unit of good X would be nothing but equal to 1. Right? That would be nothing but equal to $1. So that's what you have to write. Okay. Now the second part says, all right. The second part says, calculate total net benefit if she consumes 5 units of X. Now we all know that the net benefit, I had done this earlier, the net benefit is given by total benefit minus total costs, right? So let's see when she consumes 5 units, what's her total benefit? Okay, let's go up. All right, so when she's consuming 5 units of good X, her total benefit is $41. And what's her total cost? 5 units of good X is being consumed and price per unit of good X is $4. So 4 into your 5, that gives us $20. So $20 is your total cost that she is incurring. Now 41 minus 20 gives you $21. That is the net benefit. Since net benefit is positive, so yes, she is good to go with this 5 units of consumption, right? Okay. Then let's say the third question says that currently she is consuming 4 units of X good and 2 units of Y good. That's what she's currently consuming, right? And the question asks you, use marginal analysis to explain why this combination is not optimal for Anita. Now, we all know that for the optimal combination, this should hold true, right? Marginal utility of X divided by P of X should be equal to marginal utility of Y divided by P of Y. That's your law of equi-marginal utility. You remember that, right? So either it's marginal utility, marginal benefit, one and the same thing. Now let's see if marginal utility of X per dollar of X is equal to marginal utility of Y per dollar of Y with this consumption of X and Y. So for that, first let's calculate this, right? I did this. So mu of X by P of X, right? That's 16 divided by its P of X is your 4. So 16 divided by 4, that's 4. 12 divided by 4, that's 3. 8 divided by 4, that's 2. 4 divided by 4, that's 1. 1 divided by 4 is 1/4. Similarly, we do it for Y. So that's 10 divided by 2 since price of Y is 2. 8 divided by 2, 6 divided by 2, that's 3, 4 divided by 2, that's 2, 2 divided by 2, that's 1, right? She's consuming 4 units of good X and 2 units of good Y, all right? Now with that, she's having marginal utility per dollar from X is 1 and marginal utility per dollar Y is 4. So definitely that the ratio does not hold, the ratio of the two is not equal. That's 1 and that's 4, right? So this is not the optimal combination for Anita, okay? Since the marginal utility derived per dollar from Y is more as compared to the marginal utility derived per dollar from X, 4 is higher than 1. So Anita would be consuming more of Y good. All right? Okay. Now, the next question is, so since this is not the optimal combination of the two goods for Anita, so let's calculate the optimal combination for two goods for Anita. Let's see what's the optimal combination for two goods for Anita, right? So again, this equation, this ratio should hold true, right? The ratios, the two ratios should be equal to one another, all right? So let's see where these two ratios are equal. Okay, let's go back to the table. Now in this, there's a catch. You also have to remember that the optimal combination would be the one where, yes, this ratio holds true, and so respectively, we will look at the, the quantities that she is consuming. But then we also understand, or we also look at whether the consumption of those quantities, given the prices of the two goods, satisfy her total income or not. So the total expenditure by Anita should be exactly equal to the total income that she has, which in this question is given out to be $20. It should not be, the spend should not be less than 20. It should not be more than 20. All right. So first of all, let me take just any example. So let's say 4. The mu of x by p of x 4 out here, right? I'll take this one. Okay, is 4 out here and it's 4 out here. So these two are equal for y and for x. Respectively or correspondingly, she is consuming 1 unit of good x and she is consuming 2 units of good y. But let's see if that satisfies the income constraint that we have, right? So 1 unit of good X multiplied by 4, because 4 is the price of good X, gives me $4. And for Y, 2 units multiplied by the price of good Y, which is $2 per unit, gives me 4. 4 plus 4 is 8, which is less than $20. So this is not the optimal combination for Anita, in spite of the fact that these two ratios are equal to one another, right? Similarly, you just have to look out for different, for different combinations like this that would satisfy actually the income level as well, the income, the budget that has been given to you. So I take up, let's say this one, the second one, which is 2 out here and 2 out here, right? These two are equal. Correspondingly, she's consuming 3 units of X and she's consuming 4 units of Y. So now let's see if that satisfies the income level or not. So we know that the ratios are equal to one another, right? Does that satisfy? 3 units of X multiplied by 4 gives me 12. 4 units of Y multiplied by 2 gives me 8. Yes, 12 plus 8 gives me $20. So this is basically the optimal combination for Anita. 3 units of X and 4 units of Y, since it satisfies the income constraint as well. All right. The last part that I have is conditions, actually, few conditions, right? So what you have to tell me is that what happens, right? We have to indicate whether each of the following will cause the optimal quantity of good Y to increase, decrease, or stay the same, right? These are the conditions that I'll give you. And you, based on that, you have to tell me that whether the optimal quantity of good Y will increase, decrease, or will stay the same. Okay. So the first condition or the first situation is that if the price of good Y doubles. So if the price of good Y doubles, then what happens? Price of good Y doubles, that becomes 4 because earlier it was 2. So this entire ratio falls. And since the marginal utility or the benefit derives from good Y falls, so the consumption of good Y also falls, right? The second condition is, let's say that Martha's income falls to $10. So earlier it was $20. Now it falls to $10 with no change in prices. All right. In that case, since income falls, so the consumption of good Y also falls. You can check that from the table as well. So when the income level is 10 and there is no change in prices, you can see that what combination will she have, right? Third condition is if income doubles and the price of both goods also double. In that